Hello, welcome to College Algebra. Today we're going to talk about Chapter 5. Chapter 5 is talking about the system of equations. So this is the idea is different than we have learned before. We learned about how to solve equation in one variable. And in order to solve the variable, we have to have one equation. Today we're going to learn about how to solve for two variables. And in order to solve the two variables, we need to have two equations. So we're going to learn about how to solve the two variables in two equations. We call these two equations a system. We call it a system of equations. Of course, we can have more than two variables. We can have a system of three variables in two or more equations. But in order to have one solution, I have to have the number of the variables equals the number of equations. Let's see how we define that. Again, the solution would be an ordered pair when I have two variables. Let's see that. So today we're going to talk about the system of equation. So the system of equations is an ordered pair. X and Y. They must be used together. Okay, and the solution must be in an ordered pair as well. And also X and Y. Okay, so now I'm going to give you a solution, X and Y, and I give you a system of equations, and you tell me whether this solution is correct or wrong. Let's get an example. I have my system of equation, and I'm going to write the system equation in this way. 5x minus y equals 11. And the other one is x plus y equals 7. I want to check whether 3 and 4 is a solution for this system. So how can I do that? So this is x and 4 is y. I'm going to plug x is 3 and y is 4 in both equations. If the solution works in only one, that is not solution. The solution must work in all the system, all the equations of the system. Okay, let's try that. 5 times 3 minus 4 is 5 times 4 is 3 is 15 minus 4 is 11. And here is 11, so the first one correct. Let's try the other one. X is 3 plus y is 4, that gives me 7. So here's the answer, 7 is correct. Therefore, 3 and 4 is a solution. Okay? So you plug x and y in both the equations. Let's get another example. We have given the system of equation 2x plus 3y equals negative 3, and I have x minus 8y equals negative 5. Now check if negative 3 and 1 is a solution. So x is negative 3, y is 1. So I'm going to plug negative 3, so 2 times negative 3 plus 3 times 1. And how much is that? So 2 times negative 3 is negative 6, plus 3 times 1 is 3, so I get negative 3. Correct? Let's plug it in the second equation. So I have negative 3 minus 8 times 1, which is equal negative 3 minus 8 is a negative 11. Uh-oh, this one does not equal to that. Therefore, this one Negative 3 and 1 is not a solution. Although this solution works with the first equation, however, it's not a solution of the system. Okay? It works in only one equation, but to be a solution, that ordered pair, to be a solution for the system of equation, it must work in each equation of the system. Okay? So we have two cases here. One, the ordered pair works for both equations, while this ordered pair works in only one equation. This is a solution, that is not a solution. All right, let's get methods how do we solve this system of equations. How do we get this pair? How do we get that pair? Not this one, but how do we get this one? So there is three methods. We're going to learn about them in this chapter. The next chapter we're going to learn about the matrices, and that would be the fourth method. So the first method is graphing the solution. Graphing solution, or graphing the lines, graphing solution, let's say graphing solutions. And here we graph each line of the equations, or each line of the system. Since each equation is a line of this system, and the intersection between the two lines would be the solution. Okay, so you're going to graph the two lines, and if they intersect in one point, I have one solution. If they intersect in more than one point, I have more than one solution. If they don't intersect, then I have no solution. So let's graph three lines here. So number one, I have one line is that way, and the other line is this way. So here is, I'm going to call this, I think this is in the system of equation, 2x minus 3 equals 1, and I think it's y. And y equals negative 1/2 plus 4. So if I get this solution, here's the solution here. So this point is the solution, and it has two coordinates, x and y. So based on this equation, I got 2 and 3. That doesn't look like 2 and 3, but what I mean is it's only one solution. So in this way, I'm going to call this solution, because I have a solution. Once I have a solution, I call the system is consistent. Okay, the system is consistent, and I have one solution. So let's write this down here. One solution, and the system is consistent. And since the value of x is not dependent on the value of y, or the value of y is not dependent on the value of x, we call this, the system is independent. Okay? So three characteristics of the system: one solution, consistent system because I have a solution, independent because the two variables are not depending on each other. Okay, let's get another example. Let's say this is, what is -4? So this is a line. And this actually is two lines, and these two lines on the top overlapped. So I call this, if I see the system here, I have 3x minus 2 equals 2, minus y equals 2, and I have the other equation 6x minus 2y equals 4. Look at this system here. The second equation is the same as the first equation but multiplied by 2. If you factor 2, you get 3x. Factor 2, you get negative y, and factor 2, you get 2. That's why the line is the same for the two equations. In this way, the solution is because they intersect in every point in the line. They are overlapped. So how many solutions here? So here I have infinitely many solutions. Okay? Now, do I have solution? I do have solutions. Therefore, the system is consistent. And the last thing, the two variables are not independent because the value of y depends on the value of x. So the variables are dependent. Okay? So now I have two cases so far. One, I have one solution. The other one, I have infinitely many solutions. Maybe I have a room here. So what if I have one line is like that, and the other line this way? And how many these two lines are on parallel? At how many points they intersect? They never intersect. Therefore, I have no solution. No solution. Okay? And here, since I have no solution, I call the system inconsistent. So here, the system is inconsistent. And since it's inconsistent, I don't have a value of x or y, therefore there is no dependent or independent. So I hope you understand this idea. Okay, I have three cases of the system. One solution, the system is consistent, and the variables are independent. One line, the two lines are overlapped. I have infinitely many solutions. The system is consistent since I have solution. And the variables are dependent because each point x, y depends on x, y depends on x. The third case is the two lines are on parallel, and that means that they never intersect, therefore they have no solution. And now, since I have no solution, the system is inconsistent. Alright, let's go for the methods how to solve these equations and how to find the system. So the first idea is to do it by graph. If I have one solution, I find the solution. If I have infinitely many solutions, I write here for this one, I write the solution. I have this solution here. So I write it as this. Here's 2, 3, x and y, such that the system is x and y, let's call it, and 20, and is 2 and 3. Okay? The second one, this one, okay, you write x and y, and they are dependent, so you write any of these equations. So x and y equals such that 3x minus y equals 2. And here there is no solution, so I'm going to call it the empty set, or 5. Okay? All right. Okay, let's get some methods how to solve this. So we went through the graphing, the first one. The second method is substituting. So let's see how we do that. So number 2, substitution. So let's get the system here. 4 or x plus 3y equals 11, and 4x minus y equals 18. All right, so the idea here is we solve for one variable in the first equation and substitute that variable in the second one. So let's solve for x in the first equation. So I have x plus 3y equals 11. I will subtract negative 3y from both sides. So I have x is 11 minus 3y. Okay? Now I got a value of x. So now in the second one I'm gonna plug, and instead of x I substitute x by 11 minus 3y. So let's do that. So 4 times, not x, but 11 minus 3y, and then minus y equals 18. Okay, now we distribute. Now I have one equation, one variable in one equation, and it's a linear equation. We learned about that before, so it's easy to be done. 4 times 11 is 44, minus 4 times 3y is minus 12y, minus y equals 18. Okay, let's combine the two y's. So 44 minus 13y equals 18. Subtract 44. So 44, so I have negative 13y equals negative 26. Divide by negative 13 both sides, so y equals 2. Now, I got the value of y. We go to this one here, back substitution, we call it back substitution here, and I'm gonna plug y equals 2 and get x. So x equal 11 minus 3 times 2. So let's see what I got. 11 minus 3 times 2 is 6, so I got 11 minus 6 is 5. So x is 5. Now, the solution, the ordered pair is x is 5 and y is 2. You must write the solution in this way. So again, the substitution method is to evaluate, to solve for one variable in the first equation and then substitute that variable in the second equation. Okay? So this is the second method. The third method is the addition. So addition is easier than this one. So if I have the system, this is the addition, and this is number 3. So I have this system, 3x plus 7y equals negative 1, negative 3x plus 4y equals negative 10. For addition, you make sure that the number that you put the two equations in the standard form. Ax plus by equals c, the standard form. So you can't leave, this is the standard form. You can't make this equation like that, negative 7y minus 1. It must be in that form. You can't leave it in this form. So you have to make the number to the right and x and y to the left. Okay, now the idea here is to use the addition. What's going to happen if I add 3x minus 3x? I'll get 0. So therefore I eliminate x. That helps me to eliminate x, and I have one variable. So if I add these together, I get 0x, which is 0, and then plus 7 plus 4 is 11y, and negative 1 and negative 10 is negative 11. So I have 11y equal negative 1, so divide by 11, so y equals negative 1. You see how easy it is? Now, you plug negative 1 in any of these two equations. So I'm going to plug y, negative 1 of y here in the first one. So I have 3x plus 7 times negative 1 equals negative 1. So 3x minus 7 equals negative 1. I add 7 to both sides, so 3x equals 6. And then divide by 3x equal 3. So now I got y is negative 1 and x is 3. So the solution is one solution, and the system is consistent, okay, and the variables are independent. So the solution is the ordered pair, x is 3 and y is negative 1. Okay, the system is consistent and independent. Okay? Alright, let's get one more example of how to do the addition. I'm going to stick on the addition here. Okay, so I have the system 14x equal 7y plus 6 and 3x plus 5y equals 5. Alright, so of course there is a way to use the substitution here, but you're going to go for the idea of fraction, because I have to divide by 14. I do not recommend that. So let's use the addition method. So I have to put x and y on one side and the number in the other side. So I'm going to reform the first equation. So this is equal. So I'm going to subtract 7y. I have 4x minus 7y equals 6. And here I have 3x plus 5y equals 5. Now, what should I do here? I can't subtract or add. When I add them, I can't eliminate one variable. So now I have to do manipulation. And what I'm going to do is I want to make y is the same, one negative and one positive. So if you multiply the first one by the coefficient of the second one, and the second one by the coefficient of the first one, you must have the same number. Let's see that. What I mean here, let's do another color. If I use here, and I multiply the whole equation by 5, and this, the whole equation, I'm going to multiply this by 7. Sometimes negative 7 if they have the same sign, so I need to have one positive and one negative. So when I add them, you'll cancel out. So let's do that. I have to multiply 5 by each term here. So 5 times 4x is 20x. And 5 times negative 7 is negative 35y equals 5 times 6 is 30. Okay, then the second equation, 7 times 3 is 21x. 7 times 5y is plus 35y equals 7 times 5 is 35. Oh, now I have difference. So now I have minus 35 and plus 35, so I can cancel them out. Now let's add. So 20x plus 21x is 41x. And y is cancelled out. And 30 plus 35 is 65. Okay? So now x is, I divide by 41, so I have 65 over 41. Okay? I think, okay, so I think I missed a number here, so that should be 14. So I just miscopied the problem. So if that 14, 5 times 14 is 70, so that would be 70. And here is 91. Well, that should be over 91. And this is divisible by 13, so x equal 5 over 13 divided by 13, that must be 7. Okay? Yeah, sorry for mistyping here. I forgot the one. Alright, so now I got x. Am I done? No, I have to get y. Let's get this y because this is easier one. So I'm gonna plug 3. Actually, I like the first one. Why is the first one? Because this is divisible by 7. Okay, so 14 divided by 7 is 2, so this is going to be easier. So I would say 14 times 5 over 7. So you see, while I'm doing it, I figured out, oh, I can cancel the fraction here, because I don't like the fraction. Okay? Minus 7y equals 6. So I got the original equation here. So 14 divided by 7 is 2. 2 times 5 is 10. Minus 7y equals 6. Now I subtract 10. So I have negative 7y equals negative 10 plus 6 is negative 4. Divided by negative 7. So y equals negative 4 over negative 7. Therefore y is 4/7. So now my solution is x is 5 over 7, comma y is 4 over 7. And now again, I have one solution, and the system is, since I have a solution, so it's consistent, and these two variables are independent. Alright, well, thank you. Next video we're going to continue in these methods, and we finish section 5.1. Thank you.